Same thing as the last one. We want to find out where this function equals 1, so we got to find out where its individual parts equal 1. And you'll notice here, I'm trying to be a little scary. I'll put a pi in here. That's not going to make a big difference. So when you see pi there, don't freak out. It's not really doing anything to you. It just lets you know where each function is defined on what intervals. So the main number we want to look at here is 1. We want to find out where does each part equal 1. So where does 3x minus 2 equal 1? Well, that happens when x equals 1. You add 2, divide by 3. Okay, so 3x minus 2 equals 1 when x is 1. But 3x minus 2 for g of x is only defined for when x is less than negative 2. So 1 will never ever get plugged into this thing, so 1's not an answer. So let's try the next one. X squared plus 5 will equal 1 when x squared equals negative 4, and since that's an imaginary number there, that doesn't have any answers either. That's pretty nice. So g of x doesn't equal 1 anywhere yet. We got to check this log thing. So where does log base 3 of x plus 1 equal 1? Well, to solve a logarithm equation, you rewrite it exponentially. So that says x plus 1 equals 3 to the first power, which is 3. And that means x is going to be 2. So when x is 2, log base 3 of x plus 1 will equal 1. Unfortunately for us, not unfortunately for this equation that we're trying to solve here, I guess, when x is 2, you're not plugging it into log base 3 of x plus 1. You're plugging it into x squared plus 5. So even though 2 makes log base 3 of x plus 1 equal 1, it does not make g of x equal 1 because you're not plugging into that function. You're plugging into x squared plus 5. So x equals 2 is not an answer. So g of x never ever equals 1. So no solution.